new video. In this video, we will again see some of other topics that are not given in this Excel sheet. So the topic in today's video is the memory layout in the C programs. So it is actually important because whenever we use recursive programs, we have to actually know what activation record is and how the uh, program is running, so that we can output our correct result. And so what is the memory layout of C program? Actually, this is the layout. You can say it as a blueprint of memory, which is used to store the C programs. So these are having five um, topics, like five segments. So first of all is the text segment, then is the initialized data segment, then is the uninitialized data segment, then there is heap, and there is stack. But this, do not confuse this heap as the heap data structure. Both are different. So this heap is in the memory, and the heap data structure is another thing that we will discuss in some other video. So let's see one by one everything. So a text segment is actually is nothing but the code segment, okay? And like it is one of the section of a program in an object file or in a memory which contains executable instructions, okay? So as a memory region, a text segment is placed below the heap, okay, or stack, in order to prevent heap and stack overflows from overwriting it. So as you know that it is stored in the lower address side, and the stack and heaps are stored in the higher address sites. So usually this text segment is shareable, so that only a single copy is needed in memory for frequently using it, okay? So as text editors and C compilers and shells and other require more frequent use of checking what is written in the program, that's why it is shared, okay? Also, it is sometimes read only, because we do not want some other process that is running in parallel to this to, like let's say we are doing some like we are seeing some movie, and we are also executing a C program at with parallel in parallel. So we do not require that movie instructions to hamper our C program. That's why it is sometimes, or most of the time, read only, okay? Now coming to the initialized data segment. So this is simply the data segment which has the portion of virtual address of the program, okay? So this contains global variables, static variables that are initialized by us, okay? So initialized by the programmer, the user, okay? Now note that data segment is not read only, okay, since values of the variables can be altered at runtime, and this segment can further be classified into the initialized read only area and the initialized read write area. So these two things can happen here, like it can be read only or read write only, okay? Let's take an example. Let's say you define a character array hello world in C program as a global variable, a global string, and you have this int debug equals to 1 as a global as well, okay? So it, whenever it is a global and it is initialized, so it will be first of all initialized in read write area, okay? But whenever you have a global C statement like constant char string the hello world, so it is initialized and cannot be changed its value, as it's a constant character star string, so it cannot be changing its value in the instructions given in main method. So it makes the this string literal hello world to be stored in the initialized read only area of the character pointer. So this will be stored as a read only, and above these two will be stored as read write, okay? So now one more example is that static int I equals to 1 will be stored in data segment, and global I int I 10 will be stored in data segment, but the static one will be stored in the read only, and global int I will be stored as read write, okay? So this thing is important. And now coming to the uninitialized data segment. So it is called BSS sometimes because of the ancient assembler that used to operate, and its full form was block started by symbol, because it was it always used a symbol to start a block, and we could actually find out whether the block has started or not by just seeing the symbol in the front. Now in this data in the statement in this segment is not initialized. Let's say you just declared a variable like int I or int j, anything, then it will just go into this uninitialized data fragment or segment, and in the kernel side, like it will initialize the variable to arithmetic 0 by itself whenever before the program gets executed, okay? So in the uninitialized data starts at the end of the data segment and contains all global variables, static variables that are initialized to 0 or do not have explicit initialization in the source code, correct? Now for, as I told you, that static int I would contain in the BSS segment because it is not initialized, and the global variable declared int j would also be contained in the BSS segment, that because it is not initialized. Remember, there is just a slight difference in these two, uninitialized and initialized data, that in the initialized data we actually initialize to the variable the value other than 0, and in this uninitialized data we either do not initialize a variable with a value, or we just initialize them as 0. Okay, now coming to the stack. So stack and heap are actually taken into one segment only, because let's say you do not know what the stack size will be in the runtime, and same is the case with heap. So for that case, to utilize the memory efficiently, you take, let's say, stack sometimes take 500 values and it is coming here. Okay, and we are not using heap in the code, so not that much. So like memory is efficient because stack will be taking 80% and heap will be taking 20%. And let's say in another C program the heap is used more often, so we will be having 80% heap and 20% stack. So like this, we can actually have dynamic sizes of stack and heap with the maximum utilization of space. Okay, that's why they are stacked like these. Now the stack always grows in the downward direction and the heap always goes in the upward direction, as the name suggests. And when the stack pointer meet the heap pointer, free memory was exhausted. So let's say they are pointers that are pointing to the last value of the stack, like last memory location of the stack and heap. When they become equal, so we have exhausted our this, that is the free memory that was available here. Okay, so with the modern language address spaces and virtual memory techniques, they may be placed almost anywhere, but they still typically grow in opposite directions. So basically you have to put these two segments in more towards the higher address side. Okay, but yeah, still in the modern computers they may be placed anywhere, but still they will be growing in the opposite directions, correct? And the stack uses the LIFO structure, that is last in first out structure, and typically is located in higher parts of memory, as I told you. And on the standard PC x86 computer architecture, that is it grows towards address 0. So tell me whether this one is a little endian or big endian. So if you do not know, first check out my video where I discussed about what is little endian and big endian, so you will know that whether this x86 PC is little endian or big endian. Okay, so do let me know in the comments. Now on some other architectures, it grows in opposite direction. Now, a stack pointer register tracks the top of the stack. It is adjusted each time a value is pushed onto the stack. The set value pushed for the one function called term is stack frame. A stack frame consists of minimum of return address. So this is basically what I told you, that it grows in here and it can sometimes take 80% of the size, 50% of the size, or 20% of the size. So the chunks for one function call, it takes like the space it takes for one function call is regarded as the stack frame. Okay, and it returns the minimum address. Let's say you are having some C program and you are let me check whether they are having a C program here or not. So no, they are not having, but let me explain you real quick. Let's say, yeah, they have given here. So let's say you are calling a function right here. Okay, and let's say this is a function. I know this is not, but for understanding, let's assume that. So basically whenever this function will be called, so you will be pointing, we will just go in this, but how will the program know where, like where to return again? So that's why the stack will be pointing to the return address, like to the address of this return 0 after this activation is, so that after this function is called, we can actually perform the next instruction in the main function, correct? So like this it is stored. And yeah, stack where automatic variables are stored along with information that is saved each time a function calls. Yeah, as I told you, so each time function is called, the address of where to return to and certain information about caller's environment, such as some of the machine register are saved on stack. So as I have just explained you, they have written that only. And the newly called function, they allocates room on the stack for its automatic and temporary variable. Yeah, same thing. And this is what, like in the recursive function you must know how the stack is called and where it will return, so that's why it is required. Now coming to the heap. So heap is a segment where dynamic memory allocation usually takes place. So in stack actually they are having continuous memory allocation, but in heap it is not the case. Okay, so in heap there is a whole memory address and we store values in different places. And that is the heap, and it actually starts from the BSS segment and goes towards the stack segment. Okay, and the heap area is managed by malloc, realloc, and free, and which may use the BRK and SBRK system calls. So basically what they are saying is that we can manage these malloc, realloc, and free to actually manage the heap area, and can also be this area can also be managed by the brk and sbrk system calls. And one thing is to note that whenever we have a heap that is there, we always need to free that part of the memory explicitly, because the compiler will never do garbage collection itself. So we will discuss this as well in some other video, but as of now just you remember this thing. And the heap area is actually shared by all the libraries and dynamic loaded modules in the process, so it is also not thread safe, because all the threads in the process can see what is in the heap memory. Okay, so this is actually not useful when you do not want other thread process to have the understanding of this heap area. Okay, so like this heap is also there. Now let's see how you can see the this memory layout in the output whenever you run a program. So just this size method is required to check the memory layout. See how cool is that? So you just need to write size and the memory layout bytecode that is generate, like, sorry, not the bytecode, the a dot out file that is actually generated whenever we have the C program run. So you can see that as we have just a normal C program with no initialization and just a return 0, then they are taking this space. Now let's say you have this int global. So this is not initialized, so it will go in this uninitialized data, okay, segment. So as you know that this bss was first of 8, and as we have declared an int that takes 4 bytes of data in the memory, so it will be stored in here. So 8 plus 4 is 12, that's why we have 12 here. Now let's say we have another function where we declare this one, but we also declare the static int I that is also uninitialized. So again this will go, these two will go in this bss. So total 4 bytes for one int and 4 bytes for this int, so total is 8 bytes. So from this the initialize, so the initial bss value was 8, so it will be increased to 16 because 8 plus 8 is 16. Okay, now let's say we have another function C program that in which we initialize this variable and do not initialize this global variable. So this global will be stored in the bss, and this will be this I equals to 100 will be stored in the initialized read only data segment. Okay, so that's why the data value that is shown here is now increased to 255, and bss is only now 12. Okay, um another thing is again here that the global equals to 10 is given here, and int I equals to 100 is given. So as they are initialized, so they will be stored in the initialized data segment, but the global equals to 10 will be read write data, and the static int I equals to 100 will be read only data. Okay, so this was it for this video. I hope you liked it, and please do check it out, the playlist that I have created, so that you can also see the other videos and can understand other topics as well. So till the next video, keep learning and keep watching.